Assalamualaikum. My name is Filza Shazalina binti Mausipian. I am from Group C, S2G1. We are going to present about AI project management for traffic sign recognition system using CNN to enhance autonomous vehicles navigation. This project will be presented by Nur Najwa, Lee JC, Filza Shazalina, Disitra, and Siti Nurjihan. In recent years, the growth of autonomous vehicles has increased the importance of traffic sign recognition system. This system allows vehicles to automatically detect and understand traffic signs such as speed limits and stop signs, which are critical for safe driving. In this project, AI techniques, specifically CNN, are used to perform traffic sign recognition. However, developing an AI-based system is not simple. It involves several complex stages such as data preparation, model training, testing, and evaluation. Therefore, effective project management is essential to ensure the project runs smoothly. This project serves as a case study on how project management practices such as structured planning, task coordination, risk management, and progress monitoring, which can be applied throughout the system development lifecycle. By applying proper project management, the project was completed on time and successfully delivered a functional traffic sign recognition system that supports autonomous vehicle navigation.
I'm Jihan and I will explain about the tools and platform used to develop our system. First, Python was chosen as the main programming language because of its simplicity and strong support for AI and deep learning. It allowed us to handle image preprocessing, model training, testing, and evaluation efficiently. Next, TensorFlow and Keras were used to build and train the convolutional neural network. These frameworks made it easy to create layers such as convolution, pooling, dropout, and fully connected layers, and to experiment with different model designs to improve accuracy. We also use Google Colab for development and training since it provides free GPU support which greatly reduced training time. It also allowed team members to collaborate easily through shared notebooks without needing high-end hardware. Additional Python libraries supported the project. OpenCV was used for image preprocessing tasks like resizing and normalization. NumPy handled numerical operations. Matplotlib was used to visualize results such as accuracy and loss graph, and scikit-learn helped with model evaluation. GitHub was also used for version control and teamwork, allowing us to manage code changes and keep everyone working with the latest files. Overall, these tools help us build an effective system while keeping the project collaborative and completely zero cost.
Good day, I'm Lee JC. For detail on AI project management, we have breakdown into the 9 knowledge areas. First, for the scope management, we have used the work breakdown structures to divide our tasks. The design, development, training, testing, and the demonstration of CNN model is included in our scope. However, the hardware integration and real-time deployment are excluded in this project. For the time management, our project duration is start from the 9 May 2025 until the 23rd June 2025. We have built the Gantt chart using the Microsoft project for the schedule planning. This is the example of the Gantt chart we have built using the Microsoft project. For the cost management, we have utilized the zero budget project approach where we use the open source tools and the free platforms such as the TensorFlow, Keras, and the Google Colabs. We don't have the hardware or licensing cost. For quality management, our target model accuracy is more than or equal than 95%. We have also ensured our code is clean, structured, and well commented by regular peer code reviews. For communication management, we have used the WhatsApp, GitHub, and Google Meets as our communication platform. For risk management, we have identified a few key risks such as the module accuracy challenge, the data quality issues, and the schedule delays. Our mitigation strategies are continuously model validation, regular team meetings, and also the peer code reviews to reduce the negative project impact. The procurement management, since all dataset and tools we use are free, so we don't have the financial transaction required and also the formal procurement process. For project integration management, we have integrated the activities across the data preprocessing, CNN model development, testing, and documentation. We have ensured all project tasks follow the planned scope, schedule, and quality objective. We have also managed the tasks, update, issue tracking, and change requests using the GitHub. We have coordinated team contribution to ensure the smooth workflow and the timely project completion.
Hi, my name is Najwa and I'm going to present the flow, algorithm, and the problem solving. The flow begins with the use of a traffic sign image dataset prepared during the project. Then, the images are pre-processed to ensure consistency across the dataset. These steps include resizing images to a standard dimension and normalizing pixel values to improve model learning efficiency. After preprocessing, the dataset is split into training, validation, and testing sets. The processed images are then passed to the CNN model, which perform feature analysis and recognition. The CNN outputs a predicted traffic sign category, which represents the final recognition result of the system. This project used CNN for image classification. It was selected because it is effective in image recognition tasks and capable of automatically extracting meaningful features from visual data. The CNN processes images through multiple layers, which are convolution layers, pooling layers, and fully connected layers. The final layer applies a softmax function to generate probability values for each graphic sign category, allowing the system to select the most probable classification. Several technical challenges were encountered during the development and testing of the system. One challenge involved model overfitting, where the CNN performed well on training data but showed reduced accuracy on testing data. This issue was addressed by refining the model structure and applying regularization techniques. Another challenge was the similarity between certain traffic signs, which caused misclassification during early testing. This was improved by training the CNN with a more diverse set of images to help the model better distinguish between similar signs. Lastly, collaboration issues occurred when multiple team members worked on the same code base. These issues were resolved by using GitHub version control and structured updates, which improved team workflow.
I'm Rishitra and I'll be presenting about the project implementation and output. So for the environment, the library integration setup, we need to install the library package first by using the pip command below, and then import the libraries involved in order to achieve the functional traffic sign recognition system. So these will be the import libraries. And then for the system implementation and output, it first starts with acquisition of data and pre-processing, which is the execution phase, where the dataset was automatically labeled by iterating through its 43 class folders and assigned to its numerical ID. Then the images will then standardize through resizing, normalization, and a 70-15-15 data split to ensure consistent input. As for the CNN model architecture and development is the technical phase, where CNN uses convolution and max plane layers, and these are the filters, and then drop out flattening tags and softmax layers. As for the callback, we use it for the quality auditing. We use early stopping for quality auditing callback to monitor validation loss and automatically stop training if no improvement has occurred. And this is for the final validation, which is the technical testing, where the model was audited through model evaluate a test dataset with test accuracy serving as the KPI. And then we achieve a test accuracy of 99.59%, which exceeds the planned 95% threshold. This confirms that the project meets its quality and its performance requirements. As lastly is for the configuration management, which is the post-implementation and closing, where all source code, trained models, and performance reports were uploaded to GitHub to ensure version control, traceability, and deployment readiness. Now this shows the contribution of each group members in GitHub. As you can see, member 1, 2, 3, 4, 5. As you can see, for the project management, it's handled by Jihan, and for the data part, it's handled by Filza. For the demo part, it's handled by Najwa. And for the model part, it's handled by Rishitra. And for the notebook part, it's handled by Jessie. And this shows the number of comments of each group members. That's all from me. Thank you.
In conclusion, this project successfully developed a traffic sign recognition system using CNN. The project showed that good project management is important in handling tasks such as data preparation, model training, testing, and evaluation. With proper planning, coordination, and monitoring, the system was completed on time and was able to accurately recognize different traffic signs under various conditions. In the future, the system can be improved by adding real-time video processing using more advanced CNN models such as ResNet and testing in more challenging environments while continuing to apply effective project management practices. Next, we will continue with Q&A section. What risks did you identify and how did you mitigate them?
Now, I would like to answer the question given by my teammate about the risks and how we mitigate them. The main risks were not reaching the target accuracy, poor data quality, and possible schedule delays. We handled this by testing the model regularly, improving the dataset when needed, and having frequent discussion to keep everyone on track. Lastly, peer code reviews also helped us catch problems early.